Hey folks, welcome back. This is the first one out of 3. We have only a 3 podcast unit, which is pretty cool. But there is a lot of math. So pause the video, make sure you get a calculator, make sure you get a pencil. We're going to be doing a lot of math here. Make sure you have your periodic table. You're going to need that too. Alright, so let's get into percent composition. But before we do that, I want to ask a question. How do we know that water is H2O? How did somebody ever figure out that water is made up of 2 hydrogens and 1 oxygen? How did anybody ever figure out that table sugar was made up of 6 carbons and 12 hydrogens and 11 oxygens all bonded together somehow? How did somebody do that? I mean, you can't go and look at the thing under a microscope, so you can't see it. So how in the world would you do that? Well, we'll talk about that a little bit later, but just kind of to give you a precursor to where we're going, you had to break the thing apart. Right, so someone had to sit there with water and break it into hydrogen and oxygen. And then know that they were hydrogen and oxygen, and then figure out how much they weighed, take their masses of the 2 things, and compare them, and then get ratios and all sorts of stuff. Well, that's what we're going to show you how to do in these next 3 podcasts. Okay? So, let's start with percent composition. Percent composition tells you the relative amounts of stuff in a substance. Right? And we always look by mass. So you might want to write that down. It always tells you the relative amounts of stuff in a substance, and we always do it by mass. So percent composition is the mass of each element in a compound compared to the entire mass of the compound and multiplied by 100. Again, probably should write that down. Right? Essentially, it tells you the percent of the mass that's made up by each element in the compound. That kind of makes sense. So we're going to talk about that, but we're going to take it out of chemistry for just a second. I happen to be a special dark chocolate person. Right? Now, special dark chocolate, if you buy a particular bar of special dark chocolate, I looked on the back, and it said it was made up of 44 grams of fat, and 88 grams of carbohydrates, and 8 grams of protein, and 4 grams of other stuff. So, how do you figure out what your percentages are? Well, the first thing you have to do is you have to look at these numbers, and you have to add them all up. So if I add 44 to 88, to 8 plus 4, all right, well that's 12, plus 88 is 100, so that total thing is 144 grams. Right, now how do you figure out percentages? Now you should know how to figure out percentages. Percentages are something you should be very familiar with from previous work, but let's say that what I have is I have 44, and I divide that by 144, and that's going to give me a decimal number. So if we take that and we multiply by 100%, right, that will give us the number of 30.6. Now if you hadn't multiplied it, it would have by 100, you would have gotten 0.306. Now when I do this on a calculator, I'll take 44, divide by 144, I'll come up with 0.306, and then I'll go and move the decimal point, just because I'm too lazy to multiply by 100. You choose whether you want to do that or not. But this is a percentage. All right, we do the same thing for 88 grams divided by 144. Let's see, 88 is twice 44. It's not even up to bother going through this. It's going to be twice 30.6. Right, so my answer there is 61.1%. Now how about 8 grams? 8 grams divided by 144, and I multiply by 100%, and that's going to give me 5.6%. And 4 grams is going to be half of that. So if I take 8 and I divide by 144 and I multiply by 100%, right, I'm going to get 2.9. Sorry, that's a 4. My bad. Okay. Now I've got some rounding error going on here. Clearly with 5.6 we ended up rounding down, and the 2.9 we ended up rounding up. So when I add all these things up, remember all percentages, just kind of a reminder, this is something that you should remember. Your percentages should add up to 100. In our case, I think they add up to 100.2. All right, that's close enough for what we're doing. Don't worry about the 0.2. So it adds up to 100%. Just remember your percentages always add up to 100%. So, what is percent composition again, now that we've shown you? All right, you have to know that there are 2 ways to determine percent composition for chemicals. One is determined by experimentation. Now, did we just do that? Nope, we didn't. You didn't experiment to see how much fat was in chocolate. No, you were given a formula. And so that's the second way. If you are given a formula, you can determine the relative masses of the elements in the compound. So we are going to do this both ways. Now, if you did an experiment, and this is what the people did 100 years ago when they were trying to figure out that water was made up of H2O, was they took the mass of the sample, and they decomposed it. They ripped it apart into its elements, in this case hydrogen and oxygen. They massed the elements separately, and then they could calculate the percent composition. How much of it was hydrogen, how much of it was oxygen. Right? And then they did the math at the bottom to calculate the percent composition, which is what we just did, which is the mass of an element divided by the total mass times 100. So let's do that with chemistry. So here's an example. We want to find the percent composition of a compound that contains 2.3 grams of sodium, 1.6 grams of oxygen, and 0.1 grams of hydrogen. If you add those all up, you come up with a total of 4 grams. Well, isn't it nice? They already did that for you. All right. So we have a total of 4 grams. So how in the world do we find percent composition? Well, we take each thing separately. We look at sodium, we look at oxygen, and we look at hydrogen. Now, when I do this, I tend to write them this way because it means I don't have to rewrite sodium over and over and over again, and then oxygen over and over and over again, because I like to write all my units out. So I'm going to start with 2.30 grams of sodium, and I divide by the total, which is 4.00 grams. And then we're going to multiply by 100% because what we want is a percentage. Right? When I do that, I come up with 57.5%. Now I'm going to do the same thing with oxygen, which is 1.60, and that's grams of oxygen, and I'm dividing by the total grams. And again, I'm going to multiply by 100 because that's a percentage, and I come up with 40.0%. All right, I'm going to stop right here. Now, my last number should be, well, if I look at these entire things should add up to 100%. So that tells me this number should be, let's see, 97.5. That gives me 2.5% left. Let's see if we come up with 2.5% left. So we take 0.100 grams. We divide by 4.00 grams. We multiply by 100%. And in fact, we do come out with 2.5%. So these entire things do add up to 100. Really, that is what you want to do because it'll help you check your math in case you make a mistake somewhere along the way. All right. So let's try another one. All right, we now have 4.01 grams of calcium and 1.60 grams of oxygen. And what's the percent composition of this compound that's made up of just calcium and oxygen? All right, you try it, pause the video, see if you can do it on your own, right? And then come back and I'll help. All right, so the first thing you have to do, and hopefully you were able to do this, was you said, well, I have 4.01 grams of calcium, and I have to add it to 1.60 grams of oxygen, and that gives me 5.61 grams total of my compound. All right? Now, if you didn't get that far, there's your total. Go ahead and see if you can follow along with what we did last time. Pause the video, try it, and then come back. All right, we have two things. We have calcium and we have oxygen. Calcium is 4.01 grams, and I'm going to divide that by my total number of grams, which is 5.61. And because we're looking for a percentage, I am going to multiply by 100%. Right, the number that I get is 71.5%. Right? Which means my other one should be about 28.5% if I did my math right. So 1.60 grams divided by 5.61 grams times 100% is equal to 28.5%. When I add them up, I get 100%, which is just my check and balance to make sure I did it right. Okay. What happens if I give you a formula? Well, that's actually pretty easy, right? If I look at hydrogen and I look at oxygen, hydrogen is 1.0079. However, there are two of them. So when I multiply by 2, I get 2.0158. And that's in grams. And for oxygen, I get, well, we all know that's 15.999. Again, guys, you should be looking at this on your periodic table. Right. Now what I have to do is add these two numbers up. So I add these two numbers up, and I get a total of 18.015. Now, let me make a comment. Water, that's 18.015 grams per mole. We did that in a podcast in Unit 9. So you should get pretty familiar with seeing that number. Okay? You don't have to keep calculating it over and over and over again. Anyway, so let's look at our percent composition. So our percent composition for hydrogen is going to be 2.0158 grams divided by our total, which is 18.015 grams. I have to multiply by 100, and that will give me an answer of 11.2%. All right, pause the video, guys. See if you can do the one for oxygen on your own, and then come back. All right, oxygen is 15.999 grams, and I'm going to divide that by 18.015 because that's my total grams in the substance. I'm going to multiply by 100%, and that's going to give me 88.9%. When I add these together, I do get 100.1%. That's close enough for what I need. I'm happy. I checked my work. I feel good. All right, so here's one for MgCl2. Please pause the video, see if you can do this one on your own, and then check your work with what I do when you're done. Okay, Mg is 24.305. Chlorine is 35.453. But there are two of them. So I have to multiply, and that gives me 70.906. When I add that to 24.305 and I put that in my calculator, I get a total of 95.211 grams per mole. Well, now I want percent composition. Let's do magnesium and let's do chlorine. I have to do them separately. Magnesium is 24.305. That's how many grams of magnesium I have in my substance, divided by my total, which is 95.211. I multiply by 100%, and magnesium gives me 25.5%. All right, well, that means my other one should be 74.5%. Let's see if that happens. So I take how much chlorine I have now. Be careful. You don't want to use the molar mass of chlorine. You want to use the mass that you have actually as part of this atom, and because there are two chlorines in here, it's going to be 70 grams. So it's 70.906 divided by 95.211 and multiply by 100%. And in fact, I do get 74.5%. And these two add up to 100%. All right, guys, I really suggest you make sure that you add these numbers up to make sure they get 100%, because if they don't, it means you did something wrong. Like, for example, you used the 35.453 instead of the 70.906. So it's always a good idea to check your work when you can. So now we have a new problem. This problem says, what do you do if you have a 5-gram sample and 28.5% of it is bromine and the remainder is mercury? How do you figure out the mass of each element? Well, that should be pretty easy for you. All we're doing is doing everything in reverse. So let's say we start with a 5-gram sample, and we're multiplying by 28.5%. Well, you can take the 28.5% and divide by, sorry, that's supposed to be a percent out there, and divide by 100%. And you multiply that all out, and you get 1.43 grams of bromine. Now, I can tell you right now, since the total is 5 grams, then the rest of it is 3.57 grams. But we have to make sure that that actually comes out to be right. So let's try the other one. We have 5 grams, and we're going to multiply it by, well, whatever's left from 28.5. So 100 minus 28.5 will give me 0.5, will give me 1, will give me 7, 71.5%. So if I take this and multiply by 0.715, notice I'm just too lazy to do it and divide by 100 every time. I can do that in my head. Right? If I multiply by excuse me, 0.715, I get 3.58 grams. And that's the mercury, and that's the bromine. And when I add these up, you'll notice that I get 5.01, which certainly is close enough for what we're doing. All right, you go ahead and try one. This is the last problem we got to go through. So you go ahead and give it a shot, and then come back to me when you're done. All right, I have something that is made up of phosphorus, and the remainder is chlorine. And I have an 8-gram sample. And I have 22.6% of phosphorus, which means I have 77.4%, 0.774%, or 77.4% of chlorine. This pen and I are not getting along tonight. Anyway, when you multiply the first one out, you get 1.81 grams. You multiply the second one out, you get 6.19 grams. When you add them together, you get exactly 8 grams, which is what you were expecting. Okay? So, that's it. You should be able to do your worksheet now. If you have questions, please let me know. Come by class and ask me, and I'll be more than happy to help you. Okay? Have a great day. We'll see you later. Bye-bye.